This is to introduce Chapter 6, Polygons, and then we're going to move into quadrilaterals shortly after that. And as you know, I'm out today, and so you're going to be looking at this on your iPads. And normally my videos, I try and keep them under about 5 or 6 minutes max, but this one's going to run a little over. So what you're going to do is probably skip to the parts that you need when you hit the problems that you're trying to practice on. But I am going to cover the entire lesson and give you a few examples to boot. So let's go ahead and get started. Now, polygons. Polygons are basically two-dimensional shapes that can come in any, shape or size. And what we have is different classifications of that. You've dealt with polygons all your life. You've seen that in your previous courses. But in essence, they're just named after the sides and the vertices, number of sides and vertices. We're going to limit in our course just some basic ones. We're going to look at regular and non-regular, and we do that quite a bit. Like trapezoids, we're going to explore. That's not a regular polygon, but a square is a regular polygon. So we're going to be investigating that. Equilateral triangle is a regular, but a scalene is not. They have different properties. We're also going to spend most of our time on convex polygons and not concave. So take a look at this. Here's a convex polygon right here. And it just has nice, good sides to it. Nothing indented in like this one right here. We're coming around here and we go in, then we go back out. Whereas we're always making the same kind of turns on the outside for concave. We're going to spend a lot of time on these. And hey, I don't know why it does that. And not too much on concave, even though we haven't excluded those. Now, regular polygons have a lot of cool features, and that's really going to be the focus for today. Regular polygons, all the sides are congruent, all the angles are congruent. So as you can see when we're looking at this right here, well, nothing's really congruent, so that's a no. Same with this star. The sides are congruent, but the angles are not. They're a bit off. But here we have our what is that, a hexagon? So yes, it is. And we have a trapezoid, which is not. So regular polygons, keep that one in mind. Some terms that are extremely important. We have our sides right here. So these are sides. Okay. Our diagonal connects two vertices. Connects these two vertices. I have a diagonal over here as well. And then a vertex over here. These are all vertex. A, B, C. We name those with capital letters. All right. So we need to have those definitions down because we'll use them here in just a few minutes. Angles and polygons. You're going to have two angles that you're going to look at. Interior and exterior. Interior angle, of course, is on the inside of the polygon. And exterior, basically what you're doing is you're just extending out the line. So you're just extending out. So I can extend out this right here. And I have an exterior angle right here. Okay, you can work clockwise or counterclockwise, but once you do it, it's usually best to be consistent because then you can start confusing yourself. I tend to go clockwise. Oh, and Math Open Reference is a really good site. So what we have here is we have this cool polygon that we can play with. So I suggest going to Math Open Reference and checking out all the cool stuff. They have so much geometry stuff. As you can see, 104 plus 76 is 180. So what we have is the interior angle plus the exterior angle adds up to 180, no matter how I do it. Now we're not going to do convex, but concave. See, with concave we get a little bit different situation going on. But we can play with these all day. So moving on. Interior angle sum theorem. Well, we're going to get to that, and you're going to do an activity. You're actually going to put this on pause and start it as soon as I'm done with this little demonstration right here. So I got number of sides, 4. Number of triangles. Well, the triangles are how many triangles can you create from one vertex right here and create a diagonal. Well, I have 1 and 2. So I have 2 triangles. All right. Now we know that the sum of a triangle is added up to 180, so this would be 180. and this would be 180. So the sum of my angles is equal to 360. Okay? Just basically 180 times 2. So I'm going to come up here. Come on, little pen. My pen does not want to play nice. Draw a diagonal here. Diagonal here. And, oh my goodness, diagonal there. So I have 1, 2, 3, 4 triangles. Well, I have how many sides? I have 6 sides. 6 sides, and I have 4 triangles. I can find the sum by doing 4 times 180. 400 plus 320, so 720. Okay, and the same thing over here. I'm going to, my cursor is not working. Oh, I know why it's not on that. There's one diagonal. Yes, that's a diagonal. I need to get my cursor back. Who says I can do this? Well, anyway, I'm going to go to the mouse instead of my little pointer thing. So, I should have been doing the mouse all the whole time. Okay, so I got 1, 2, well, the mouse ain't much better. 3, 4, 5 diagonals. 1, 2, 3, 4, 5, 6 triangles. So I got 8 sides, nice little octagon, and 6 triangles. 6 times 180 will give me my interior sum of these things. Okay, heptagon is 7 sides. So we need to come up with the formula. So you're going to pause and do that little handout that I gave you. You work with your partner. Try and fill out that whole thing. You're going to find patterns. And once you get the clue bird on it, it actually only takes a couple of minutes, just a few minutes. All right? So pause. Even though I'm not pausing, I'm going to continue because I'm not going to stay here all night. All right, moving on. Oh, yes. Here's all the names. I don't lose sleep trying to learn all these names. I'm not going to test you over these. Usually only geeks know half of these, and they're usually rolling dice and slaying dragons or something like that. Well, I was a geek in college. So I kind of know all these. I didn't learn these in my math class. I learned them goofing off and doing other things. All right. So learn them if you want. Lowers your stress. It's always nice to know things in a math class that are not necessary, but they're helpful. Otherwise, I'm not going to stress over that. But refer to these names here. Your book does that a lot. So, okay. This is what you're going to be filling out. I'll go ahead and get you started on the first one. Yeah, you already started though. Okay, so name, I'm going to call this a triangle. 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 See, my writing pad is messed up. I cannot write. So this is going to be a problem when I'm doing this presentation. My mouse is really triangle. Well, close enough for government work, right? 3 sides, 0 diagonals, 1 triangle. So sum is 180. Okay. 1 interior angle. These are regular. So I'm going to take my sides and divide it into my sum. So that's going to be 60. This is an equilateral triangle. Exterior angle. Think about this. Here's my triangle. Here's my exterior angle. If this is 60, this is the supplement that has to be 120. Okay? So 120. They have to add up to 180. This plus that equals 180. So when you know your interior, whatever it takes to get to 180 gets you there. Sum of exteriors, 120 plus 120 plus 120 is 360. All right, you're going to see that 360 quite frequently. All right, so go ahead and figure all that out. Here you're going to have 4 sides, 1 diagonal, 2 triangles. So the sum's going to be 360. Moving on, and you're going to fill out the whole thing. It'll go fast after you do the first few. All right. I hope you're supposed to be on pause, by the way, and doing that. But we're now to this. So theoretically, through that exploration activity, you came up with this. Each interior angle, well, the sum of your interior angles is 180 times n minus 2. And each interior angle is going to be 180 times n minus 2 divided by your side of n. Okay, so find the measure of a regular dodecagon. That's 12 sides. Okay, it's 12-sided dice. And what you're going to do is you're going to just plug in 12. 180 times 12 minus 2. Ah, this is not me. Ooh, this makes me angry. Holy cow. Oh my goodness. I want an eraser. I need to buy new stuff at the house. What happened was this got dropped, and it's a very expensive writing pad. It just sucks right now. Okay, so we got 180 times 12 minus 2 over 12. Okay, so that's 180 times 10. 180 times 10 over 12. And I could pop up my handy dandy calculator right here. And you can also do this mentally, because that's just 6 times 2, or 6 times 2, and that's 5 times 2 or whatever. So you could do 6 into 180 is 30, and then times 5, so 150. But let's go ahead and put it in the calculator. 180 times 10 divided by 12. Boom, 150. Okay, that's what you got. Each interior angle is 150, and your exterior angle is 30. Moving on. Exterior angle sum. Sum. Oh my goodness. I need a vacation. I think I just had one. When you go around a circle, it's 360 degrees. You're making regular turns. Imagine if you're a marching band or whatever, you're going to come around and do a complete 360. So all these are going to add up to 360. So I'm going to add them. 6 plus 2 plus 2 is 10. 7 plus 3 is 10. So I got 20x. 20x is equal to 360. Alrighty? So we know that 2 goes into 36 18 times. So x is equal to 18. Alrighty. Okay, moving on. Come on, mouse. Why are you doing this to me? I did not want that to happen. Okay. Finding the exterior angle. And again, this is very long, so you're going to be putting this on pause, especially since my stuff doesn't work too well. Well, exterior angle is pretty easy. What you got to do is first find your interior angle. So your interior angle, n minus 2 times 180 over n. Well, pentagon is 5, so you're going to have 3 times 180, right, over 5. And you can throw that in the calculator real quick. 3 times 180 divided by 5 gives me 108. Okay, so each one of these angles is 108. 108. 108, so on. So the exterior is 72. They have to add up to 360. 180, good grief. My brain is turned off. It's Wednesday night. All right. So that's it. We're kind of done. 72. Let's get on to another example. Oh gosh, come on, work for me. It didn't work. All right. Here's your formulas that you're going to need to know, and you have to have these memorized because I'm not going to write them on the board on test day. Okay? They're not even part of your formula chart. So polygon angle sum theorem, n minus 2 times 180. Polygon exterior angle, they add up to 360. To find an individual angle on the interior, remember these all have to be regular polygons. If they're not regular, you can't use these formulas. It's a no-no. 180 times n minus 2 over n. Here's an example, very similar from your homework. Find the sum of the measures of the interior angle and exterior angle. So basically it's just n minus 2 times 180. And once you get the hang of this and you got a calculator in your hand, this goes fast because that's just nothing more than 12 times 180. 12 times 180. 12 times 180. Boom. 2160. That's a lot of angles. 2160. Okay. Please work. Okay. 2160. And exterior, 360. You don't even have to think about it. All of them are going to be 360. Measure of an interior angle is 120 degrees. Find the number of sides of a polygon. There's two ways to do this. One, you can use your formula and solve. N minus 2. Oh, gosh. Please work for me. I have messed up equipment. Okay, that's what I get for having a cat. Okay, N minus 2. I like my kitty. Kitty doesn't like me, though, sometimes. 180 over n is equal to 120. Well, that sounds like a complicated thing because you're going to multiply n times 120. So you got 120n, and then you distribute that. But what is the exterior angle? What's the exterior angle? It's equal to 60, right? Just do 360 over 60 is equal to 6. That gives you your number of sides. Okay? That's a much easier way to do it. I don't care which way you do it. Just do it whichever you want. Alrighty. So that gives you 6 sides. Okay, and where is my mouse? There it is. Yep. Moving on. Measure of an interior angle is given. Find the number of sides. Well, here we go again. Here we have 150 degrees. If we extend that out, please don't do this to me. Extend that out. We have 30 degrees. That's my exterior angle. Take 360, divide it by 30. And how many times does 30 go into 360? 12 times. So we have a 12-sided figure. Okay? How many sides does the polygon have? The sum of its interior angles are 900. Well, all you're going to do on this is n minus 2 times 180. And there's not too many shortcuts for this. Is equal to 900. So what I'm going to do is I'm going to just divide by 180. Oh, gosh. I have to buy a new one. I'll buy a new one this weekend or something. So I'm going to do 900 because I'm out of video production. But I didn't plan on starting new stuff. So that's 5. So you have n minus 2 is equal to 5. Add 2 to both sides. N is equal to 7. There you go. 7. So that's how many sides it has. You're probably going to have to repeat this. And again, this is not intended for one-set viewing. You're going to have to break this up into pieces so you know how to have examples for individual problems that you're going to be practicing on. You need to practice this stuff. Do not blow this off. Bad things will happen because I am not letting you have the formulas on the test. And I do expect you to know these things. Alrighty? Okay, so I'm going to put this on pause, freeze, or stop, or however I do it right here, and then get this